Hello everyone. What I've gotten to realize nowadays is that it is a well-known problem to determine a particular lift algorithm that actually provides the most optimal solution in circumventing the issue of human traffic congestion for any type of building model, and that's a very hard problem. Now, what I'd like to introduce to you today is a software that we have created that's called the LEVAX, which is an easy to use software which helps you to overcome the problem that I just explained. Now, the LEVAX provides you with the best and most optimal lift algorithm which will be implemented for any type of building model. Now, in order to use this software effectively, you would actually need to complete a three-step process to get the software up and running. Now, the first step is you will need to provide an existing XML file which contains the simulated building model data, which can be located under the File tab under the Import XML option. Alternatively, you could actually manually fill in the necessary fields. Now, the second step is to provide an existing XML file which contains the already simulated human data. A similar process to upload the XML file is basically what I just explained, and you can also manually fill in the necessary fields. And for the last step, you will either need to choose a lift algorithm of your choice from the list of lift algorithms provided, or you can simply leave the default option, which is to run all algorithms at once. Now, you will need to generate the simulated data first prior to being able to run the simulation. Now, by clicking the generate model, the simulated data will be displayed on the text field located on the first tab. The following results from the simulation will then be displayed on the second tab for your viewing pleasure. Now, the result can be saved for further analysis, or you can have them deleted to enable other simulations to be tested. Now, these functions are definitely provided by the LEVAX software, and you will definitely save time as the software is very user-friendly and it is easy to use. Efficient results guaranteed. Now let's get a bit more into the software. Now you might ask, does my computer need to have any specific requirements in order to run this software successfully? Now, you could either use Windows XP Service Pack 3 or higher, it goes all the way up to Windows 8.1, or for a Mac user, you can use Mac OS X 10.8 or above. For your processor, it can be Intel Core 2 Duo or higher. For your memory, it can be 1 gig RAM or above, or also your hard drive, you need to have at least 100 megabyte of free space. You don't necessarily need to have any internet connection because the software strictly runs on its own. It does not need any internet connection to actually run. Now, as I was explaining earlier, that you can import and export your data as files, right? So this is data that I've imported. This is a simulated building data. Okay, so say we want to run a simulation with this, or even before that, let me just explain a few more of these buttons. So firstly, as I said, this was the import and export button where you can do the same functions, only that you would be importing and exporting. So this would be importing the building or human model, and this you'd be either exporting the building or human model. For the print information, now you can print your simulated data or you can print your result. So you can print either of these fields once they have been fully generated. Okay, now also the help button, this comes very useful. This is very useful. When you click on, say you're running your simulation, you're putting together your information, if you should click on the help button, this actually helps you with some information, basically how you would go about in creating your simulated human data or your building data. right? So as you can see here, it gives you some information, basically examples of how it would actually set up. So this can be very useful for you in helping you in achieving a successful simulation. Okay, so in this, what we'll be doing, we'll be running a simple simulating building data to see if we can actually get a result. Okay, so firstly we have the information here, and step one, the number of floors, the number of meters per floor, and the number of lifts, the lifts that we'll be using in this building, right? So first, let's do a test. We're gonna select lift 1. You can basically use this option to edit it. So lift 1, the max weight, it's 700. You can get the information from here. Maximum speed per meter second, it's 3, and the default floor would be 1. Okay, so here, the number of residents, let's say the number of residents, let's say it's 10, right? Average visitors per day, let's say 5, right? Now we're going to just use all the algorithms to test. We're not going to pick a specific algorithm. It's going to basically choose which is best to actually run the simulation data. Okay, so let's go ahead and click generate model. Okay, so you say average people per level must be more than 0. Okay, so one thing that I should have mentioned earlier is that we would be importing two files, the building data and the residence data. So as you can see, the error that we got before, we would need the simulated residence data so that we could actually run the simulation, right? So now we can go ahead and click run simulation. So once we do that, we'll get our results in the simulation results field. Okay, so let's go ahead and click run simulation, and we're going to leave this for at this default to run all algorithms. So let's go ahead and do that. So here now it says simulation for all algorithms has been completed, right? So here it gives you the result. So it's saying the algorithm that scored the most points in terms of average waiting time and average travel time is the fixed sector and common sector system. Okay, and for firstly, the nearest car simulation completed in 0.46 seconds. So here it gives you the average passenger wait time, the average passenger travel time, the lift 1 idle time, all the lifts idle time, right? And here it gives you the time travel graph. So as I was saying, this actually shows you, this is the time travel graph, which actually shows you it's not saying that this amount of residents exactly. What it basically shows you is the resident is basically given a number. So resident number 363 on floor 1 would take this time to actually get to their floor, to or from, or basically to their floor, right? So as it shows here, it basically shows you for floor 1, right? This, and as you go down, it shows you for the different floors: floor 16, floor 13, floor 5, floor 2, based on which floor this resident comes from, right? Or how long it would take for the resident to actually go to that floor. It also shows the visitor as well, because as you can see here in the data, we had selected an average of 200 visitors per day, right? Now, as I was also explaining, to save the result, you can click on save result, and it would give you this in the form of a text document. It gives you the date and the time which you basically had run the simulation, and it saves it in a text format for you. So let's go ahead and save that. Alright, and tells you where it has been saved. So also you can export this data, right? Say you want to export the human model data, right? We can click on export XML and then select human model, and that it gives us the option to save it as simulated humans as an XML file. The same goes for the building model, right? Also, just in case I never pointed this out to you, you can also see the simulated visitor data here. It gives you the weight of that visitor, as well as the travel time from either floors, right? So it shows you the travel time from the ground floor to floor 4, shows you the travel time to floor 1, right? So I think this basically goes off from the weight and the number of times that they travel to the floor, right? So that's how it basically runs. Right, so as I was saying, that the LEVAX software, it's definitely easy to use, very user friendly, and basically takes a lot of time off your hand in showing you how the simulation would actually run for you. Okay,